finding the unit vector in the same direction as the given vectors. So our first one is 18, 18. This one should not surprise us too much. So the first thing to do if you want, let's call that vector v. First thing to do is figure out the magnitude of vector v. So we already did this previously. It was our first example today. It's the square root of each component squared. Without a calculator, what is the square root of 18 squared plus 18 squared? Or realize that 18 squared plus 18 squared is 2 times 18 squared. Break it up into bits. This is just 18 radical 2. Better. So to find the unit vector in the same direction as 18, 18, divide the vector v, 18, 18, by the magnitude of vector v, 18, 18. I lied. 18 radical 2. If you would do the first one, I'll do the second one once we do the first one. What is 18 over 18 radical 2? Radical 2 over 2. That means the second one is also radical 2 over 2. How do we know that that has a magnitude of 1 without doing any extra work? Where have we seen radical 2 over 2, comma, radical 2 over 2 before? On the unit circle, and the unit circle is the radius of, so the magnitude of the vector radical 2 over 2, comma, radical 2 over 2 is, which means it's a unit vector. Molto bene. Look at that. Let's do another one. Purple. Vector, we'll go vector W, look at that. 12, negative 5. What is the magnitude of vector W? Is, there you go, the square root of 12 squared plus negative 5 quantity squared is 13. So dividing each of the components by 13, what is the unit vector in the same direction as vector W? Twelve 13ths, comma, negative 5 13ths. So 12 13ths squared would be 144 over 169. Negative 5 13ths squared would be 25 over 169. 144 plus 25 over 169 is 169 over 169, which is 1. And then when you take a square root, you get 1.